New York Oracle User Group. Sorry, recording. Welcome to the New York Oracle User Group webinar. Today we're going to talk about Kubernetes, containers, microservices, mobile development with Oracle database. So would you like to move on, Mark, the slides? So with me, I have Mark Nelson. I'm Andy Tael. We're both developer evangelists, and we work in the Oracle Database Development Group. Pleased to be here to talk to you. The agenda for today is we're going to do like an introduction. We're going to talk about Kubernetes, containers, microservices, and mobile development. And then we're going to drill into a new offering from Oracle, which we call Oracle Backend for Spring Boot, to talk about what that is and what it offers. We're going to do a feature drill down on that, so we go more into detail on what it actually is. We're going to discuss mobile application development. And finally, we're going to show you or tell you how you can learn more about these offerings. And please feel free to ask questions anytime in the QA or the chat. We will have dedicated QA time by the end too, if you'd like to do that. Or you can just raise your hand. I think there's a raise hand button here in Zoom you can use. So let's talk about the introduction about this. So Kubernetes and containers, they sort of emerged to become the de facto platform for running modern applications. What the containers provide is portability, consistency, makes it easier to do externalized configuration and secrets. You can do automation of build of those containers. You do also workload isolation, and it's easier to scale it. And Kubernetes runs those containers and makes it easy, to run those containers at scale. But Kubernetes is also widely regarded to be complex, but it's evolving very, very fast to improve that, obviously, and lots of innovation is occurring. There's a survey that it says that a lot of organization has cited Kubernetes to be the central part of their digital strategy. Big words, but it means that companies are looking to that and moving towards it. Not only that, Oracle is now supporting to run the Oracle database and some other products too in production in Kubernetes. And we also, Oracle provides what we call operators to simplify the lifecycle management, like start, stop, create database. And a little plug here for a free training coming soon, which we're building right now as we speak, which is called the Kubernetes for DBAs. Subscribe to the YouTube channel and you will get a notification when that one is launched. So why microservices? The microservice architecture is a very popular way of building modern modular applications. So the applications are structured as a collection of independently deployed services. So they are very loosely coupled. They focus on like one business problem or domain, and usually owned by small teams. What that gives us, it makes it easier to build large, more complex applications quicker. It's easier to reliable to deliver because it's the teams focusing on one thing and not a very, very big monolithic architecture, which is usually the opposite. Now, microservices are not the silver bullet. Like any new architecture style, introduces its own complexities and problems and trade-offs. But right now, there are enough projects running these microservices architectures to patterns to start to emerge on how to build these applications in a proper way. For Java developers, the Spring Boot is the absolutely most popular platform for frameworks by far. I mean, we look at the numbers, we looked at job ads, we looked at Stack Overflow, we looked at GitHub repos. I mean, it's nothing even close to anything else. So why are developers using this? Well, they can write less code, get more done. And also there's a wealth and ton of knowledge out there. There's a very active community for Spring Boot. So if you run into a problem or don't know how to do it, it's very easy to find information about it. So what about mobile then? Well, mobile is not what we say like a typical business to consumer. It's a web front end application. There's also huge needs for mobile applications in like business to business communication, Internet of Things segments, especially certain industries like healthcare or perhaps transportation. The backend as a service pattern is a very popular mobile application development. It makes it possible for the developer to focus on the application instead of anything else, how it's running, how it's provisioned, how it's managed. The developer basically consumes services from a backend using APIs without worrying about that part. Right now, there are two main SDK approaches for mobile applications. One is the sort of the native one when you develop for iOS or Android, or the cross-platform one, which I think is growing really fast, which could be React Native and Flutter, which is a really interesting new technology. So the platform we launched, it's called Oracle Backend Platform for Spring Boot. Well, what it does, it makes it really easy to develop web and mobile apps anywhere with the power of the Oracle converged database. An application needs data, and obviously Oracle comes in there. So the Oracle 23c, which is out there, it's a beta version, and also there's a free edition, which you can try it out. It's all about making life easy for developers. When you hear people from Oracle talking about 23c, this is going to be the key word: developer, 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 JSON duality, and all these things that we launched. At Oracle, what we do also is we're focusing very hard on producing new offerings, SDKs, APIs, to make it really easy for data developers to access their data in their organization's database, not just 23c, like 19c or whatever you're running, but 23c is really focused on the developers. So the Oracle backend for Spring Boot and the Parse platform implements the backend as a service pattern. So microservices and mobile goes really well together. It's available right now as a developer preview. You can, if you have an OCI Oracle Cloud Infrastructure account, you can deploy it from the OCI Marketplace. It's free. Besides the fact that you have to pay for the infrastructure, which is very little. Then the platform can also be deployed on premises if need be, and actually on Azure too. We believe in the multi-cloud strategy. So let's talk about these features. I'm not going to go through all these things here. We're going to talk about them individually. But what we're saying here is, let's say the developer wants a runtime environment for their services. Well, we deploy the backend using Kubernetes. We want easy access to the database and messaging. So we have developed Spring Boot starters for Oracle technologies. We need to use service discovery, load balancing, and fault tolerance. So we're using Spring Service Eureka and Resilience for J to make fault tolerance. We also have an API gateway to be able to expose the services. We also, in microservices, the transaction management becomes quite a problem. So therefore, we have something called Oracle Transaction Manager for microservices. It's not a problem. It comes with the architecture and the patterns, really. We need workflow, orchestration, choreography. We deploy Netflix Conductor. We want to externalize configurations from applications. So we have a Spring config server there, and you don't want to talk about more of that. Observability, difficult word for me. We have Prometheus, Grafana, Jaeger, OpenTelemetry. Secure secrets management, we deploy HashiCorp Vault. And if you run on OCI, you will also have OCI Vault in your hands. We can do scale on demand, so you don't have to worry about that part. We have developer tooling, we have developed a CLI and Visual Studio Code extensions. And for the mobile developers, it's the same thing. Well, the mobile ones want to do store, retrieve data, on-device, offline storage, identity security, and all these things, caching, location, geospatial. So what we have developed is an Oracle storage adapter for the Parse platform, which lets you use the Oracle Autonomous Database as the backend data store. You can use that with any Parse app with zero code changes. All the Parse SDKs can be used with Oracle Backend, iOS, Android phone, tablet, computer, TV, car, and all kinds of languages, .NET, PHP, Flutter, GraphQL APIs, JavaScript. So this is a picture of what actually kind of gets deployed. It actually gets deployed when you deploy the Oracle backend for Spring Boot on the Parse platform. The gray boxes on top, what we call the backend ops center, sort of the service discovery, the workflow, the apps dashboard, the security, the parse, the transaction manager, and the CLI itself has the service there, which we talked to. That sort of gets deployed in the Kubernetes cluster. The app container is where you as a developer would put your applications and run it. So you have resilience for J, OpenFane, Spring Config, and all these things available. So when you deploy, we will help make sure that things are integrated into the tools. Everything's obviously running on top of the Oracle Autonomous Database, which can do relational, documents, events, spatial, graph, text search, and promoting the PDB type of models, or the database itself is running there, but then you have the PDBs running, and in an ideal world, each application has its own PDB. On the left-hand side, the big black box, that's the gateway, so we can expose our applications to the internet if we need to. We also have the Visual Studio Code extension, or the CLI, to be able to deploy the applications. Applications are obviously written in Spring Boot. The mobile app SDKs are there for iOS, Android, Flutter, which is we're going to talk about a bit more, and it all runs on the Parse platform. So let's dig into a little bit more on all these features, what they are really. First up, runtime environment for services. We talk about containers and Kubernetes there. So it's the standard open standard of Kubernetes that we run on. So you can run it on OCI as the OKE environment, Azure on premise. It's fully managed with automated scales. It has high availability by default. If you run it on OCI, and you can right size it with flex shapes and flexible load balancers. Of course, there's support. It's advanced security, well, it conforms with the Kubernetes STIG, NSA, DoD, and CISA. Obviously, you can encrypt the container scanning and signing. With Oracle, you also get operators for the OCI services and the Oracle database you can run on Kubernetes. You can choose currently from managed or virtual nodes on OCI. However, the platform we developed today only supports the managed nodes right now. You have very rich environment. You can choose from which kind of shapes you want to do, like ARM, bare metal, VMs. It's available in all regions. It's based on all open standards, really. It's nothing, no Oracle vendor locking. We just add on to it, make sure it runs perfectly fine.
Is this, should we listen to my voice for a little while now?
Yes, I think you can.
Alrighty. Okay, so another thing that we've been working on is creating Oracle Spring Boot starters. So a Spring Boot starter is basically a library that a Spring Boot developer can add to their application. And these libraries provide all of the necessary dependencies for something. And they can also do things like automatically configuring or injecting capabilities into the application. So, for example, there's a standard Spring Boot starter called Web that lets you create a REST server, like a web server with a REST capabilities. So we've started creating these for Oracle-specific technologies. So we've created them, for example, for universal connection pooling and database wallet, for advanced queuing or transactional event queues using the JMS APIs. And we're basically rolling out a bunch of these starters for all of the different technologies and APIs in the database to make it easy for people to be able to use Oracle from Spring Boot. So we're doing the starters for both Spring Boot 2 and Spring Boot 3. And we'll basically just keep rolling out more things until we have sort of complete coverage. So we're working on the Kafka API to transactional event queuing. We're working on adding a starter for using JSON collections in the database, using either the SODA API, that's the Oracle API, or using the Mongo API. Using graph data in the database, using the graph query language or the Neo4j APIs, and text and spatial and machine learning and all kinds of other stuff will follow on. These are all freely available in Maven Central, so they're easy to use. They work the same way as any other Spring Boot starter from the core or from any of the other vendors or community members. Basically, you add a dependency to your Maven POM file or to your Gradle file, and then you can add some configuration parameters if they're required, either directly into the Spring Boot application properties file or YAML file, or you could put them into the Spring config server and have them injected into your application at runtime. This is an example of using the Spring Boot starter for a Q JMS. That starter will automatically inject both a JDBC connection and a JMS connection factory into your service for you, and those can share the same database transaction. So if you wanted to do something like receive a message of a queue and then do like an update or an insert and have that in a same database transaction so that either both of those happen or neither happen, you can do that with this starter. So this is an example here of a Spring Boot component. You can see it has the standard component annotation here. And it's a JMS listener. So this is going to invoke this method every time a message arrives in this mailbox queue or topic. And it just prints it out, but this gives you an idea of how it works. If you haven't seen Spring Boot applications before, these annotations are used all over the place in Spring Boot, and they're the way that you inject sort of standard behaviors into your application. So another thing that Spring Boot or microservices developers almost always want is service discovery. Excuse me. So we include the standard Spring Eureka service registry. It was originally written by Netflix and called Eureka, but Spring have kind of adopted it, so they call it the Spring Service Registry. And what it does is it basically maintains a list of all of the healthy instances for each service that are running in the environment. So if your service needs to find another service to do something, then it can go to the registry and look up to see if there's an instance available, get a list of them. And it can then, do things like client-side load balancing or fault tolerance. So if one instance is not available, it can go to the next one automatically. That's all built into the Spring service registry client. That's a standard Spring component. So you don't have to write any code for that. That's all sort of automatically done for you. And it means when you're running your services, you don't need to know the address of other services, at build time or deployment time. That can all be, injected at runtime and can change from moment to moment. The registry is also used by other components in the system. So for example, the monitoring components can use the registry to find out which services are running, or the API gateway can use the registry to find out the endpoints for a particular service. So, all of the pieces in the puzzle sort of integrate with each other. So by default, we don't actually expose anything outside of the Kubernetes cluster unless you actually go and make a conscious decision to do that. And the way that you would do that is using the API gateway. So in the API gateway, you can go and say, I want to make this service available. You've got control over all kinds of capabilities. So there's things like traffic management to control the throttling the traffic if there's too many requests. You can do transformation to change the data or the format of the data. You can handle authentication with, for example, OAuth or basic authentication, those kinds of things. Plug into observability systems. And, you have a lot of fine-grained control over things like HTTP methods and protocols and which headers are required or allowed, cookies and all that kind of stuff. So it really gives you a central place where you can manage access to all of your services from external clients. And again, it's integrated with the Spring Service Registry and also with Kubernetes for service discovery. So like Andy said, you tend in microservices to run into, challenges with data consistency and transaction management. So there's a very popular pattern in microservices called the database per service pattern, which basically says that each service has its own database and it stores its data inside that database, and nobody else is allowed to go and mess with that data. The only way that you can get data from another service is through its public API, like its REST API, which is all very well and good, but it means, you end up with hundreds of databases potentially, and if different teams are making decisions, you could end up with all kinds of different databases, and it makes it difficult to do things like a transaction, right? Because you have different databases. So Andy was mentioning that you could use the database containers, the pluggable databases in Oracle, to give each microservice a pluggable database. So that helps address the situation to some extent, because you can then just have one, big host database. So you only have to manage one database, for updates and patches and security fixes and backups and all that kind of stuff. So that simplifies it, the management side of it. And then the other issue is, how do you handle the data consistency? And there's different approaches, have evolved. One is, just to manually do reconciliation, which is obviously expensive and error prone, and all that kind of stuff. Then another approach is you could have developers go and actually write code to detect issues. So for example, if you detect that a message has been received twice, like if you get a duplicate delivery, or if you detect that you're missing a message, like for example, if you got, message number 8 and then message number 10, you can see that number 9 got lost somewhere, and that sort of stuff. So if you can detect those kinds of situations, then you can write code to deal with them. And people start, getting into things like creating idempotent consumers, and that can, consume messages and multiple times without creating problems. But that tends to also mean you need to have idempotent producers, and it just gets more and more complex and difficult to test and error prone as well. So, the other option is to use a transaction manager. And, that's not anything new. We've, as an industry, been using transaction managers for, I think, 40 or 50 years now. And they've worked very, very well that whole time. So, they can equally be applied to this microservices architecture as they could to, older architectural styles that we were familiar with in the past. So we do have a product called Oracle Transaction Manager for Microservices, also known as MicroTx. This is freely available standalone by itself, and also as part of the Oracle Backend for Spring Boot. It runs in Kubernetes in a container alongside your microservices, and it provides support for the 3 dominant methods that are in use today in the industry. So XA, or extended architecture, long-running actions, which is also sometimes known as sagas, and try, confirm, cancel. It also will work with all of the common transaction management systems like Oracle Database and Tuxedo and all the other ones that are out there today. And it provides libraries in all of the popular languages that people use to write microservices, as well as REST APIs. So it can store the transaction state in etcd, which is the key value store used by Kubernetes in most cases, or in the Oracle database. So that provides a way to deal with managing consistency of data across multiple microservices and their data stores. I'll come back to that a little bit later on too, or maybe Andy will, when we talk about our cloud bank example. So another capability that's often desirable in microservices deployments is workflow management, orchestration, choreography, basically taking all of your microservices and putting them together into some kind of process flow. And, you have things like decision points and retries and all that kind of logic that you can build into a process. So currently we are including the Netflix Conductor open source edition in the Oracle backend for Spring Boot. We are looking at moving to the Orkey's Conductor. It's basically the same thing, but it's the people who wrote Conductor originally while working at Netflix kind of left and started their own company, and this newer flavor of Conductor is more optimized for high performance, low latency kind of scenarios, and has some better UI or newer, more capable user interface kind of capabilities. So we're looking at moving to that newer version of Conductor. Let's see, configuration. So configuration is a big challenge in microservices. So you really don't want to include the configuration in the container images, or burn it, or we call it burning it into the image. Because because it makes it really difficult to change it then, because you have to rebuild the image every time you want to change the config, which gets to be annoying and consumes a lot of space and time. But also because the configuration can have sensitive information in it, like passwords or database connection URLs or things like that you might not want to have floating around in a container image. So by externalizing the configuration and keeping it somewhere else, it means, if someone does manage to get a copy of your container image, they won't be able to, what's the word I'm looking for? I can't remember. Compromise your, your sensitive information. So in Spring, there is a configuration server, Spring Config Server, which we also include in the backend platform. And basically it keeps all the configuration data. You can group it based on keys and profiles and versions and labels and all that kind of stuff. We configure it to store the information actually in an Oracle database, or you could also store it in a vault, depending on how sensitive the data is. And Spring has got a built-in capability that's called profiles, which makes it easy to basically have the configuration injected at startup time. So you could have the same code, and depending on where you fire it up, it would get, the production configuration or the test configuration or the pre-production or whatever it might be. So now observability is also super important for microservices, because you've got all of these little bits of code running all over the place. You really need to know, what's going on, what's running, how are they performing, are there any problems? So there are a number of tools that we include in the backend platform. One is Spring Admin, which is a web UI that makes it easy for you to just go and take a look and see what services are running in the environment, see what their health is. You can see JVM statistics. You could take a thread dump or a heap dump, all that kind of stuff. You can see what Spring beans and Spring configuration has been injected into the service. You can see what endpoints they expose, what services. You can look at the metrics and the values and a whole bunch of other stuff. So that's a really useful tool to just have an overview of what's happening in the environment. We also have the applications include the Spring Actuator, which is a standard Spring component that produces a whole bunch of metrics in Prometheus format, as well as other stuff. And then we scrape that into a Prometheus database and include Grafana dashboards like this one here. This is the Spring Boot dashboard that lets you see a whole bunch of information about your services. So you may see up the top here, there are little pull downs for the application and the instance and so on, the connection pools and that sort of stuff. So this will automatically discover the running services from the service registry and populate those pull down boxes there. So you can easily go and find, which service, which instance of a service you can drill down and see what you're interested in. It gives you a whole bunch of statistics like the ones you see here: CPU usage, memory, response time. You get a whole bunch of HTTP statistics. If the service uses a database, you will get all of the database statistics as well, like connection, usage, and the number of queries that it ran and all that kind of stuff. So you get a heap of information. And you can use these dashboards to identify that there's a problem. So for example, here, you may notice like the response time is jumping here at 12:22, just before 12:30, about 12:36, about every, 8 minutes or so, something is going on. And you notice here the CPU usage also spikes every 8 or so minutes. So this is a way that you can look at this visually and say, there's a problem here, something's going on, and we want to drill down and find out what's happening. You could also create alerts on these dashboards, so you don't have to be sitting there looking at it. You could have an automatic alert if something happens to send you an email or page you or to take some kind of automated action. So as well as Prometheus, excuse me, we also include the OpenTelemetry collector, which actually runs as a Java agent. So it works at the bytecode level. You basically wrap your application with this Java agent when you run it in the JVM. So that means you don't have to write anything in your code to use this collector. It's operating completely at the bytecode level. So there's no code changes needed to get this. And what this does is it gives you traceability through all of your services as they call each other. So you can see here that a request came into the customer service to this get customers API, and you can follow through what happened. It went to the Spring controller, and then you'll see down here it actually did some, actually that might be the post. That's a little bit small for me. I think it is the post because it went and did an insert into the customer table. You can see here, and then it did a commit. And then it called another service called fraud, and some things were happening. That one also did a database insert. So this collector lets you go right down into the database and see all of the operations that took place, even putting a message onto a queue and then another microservice reading the message off the queue at the other end. You can trace through and not lose the thread. When you use asynchronous queuing between services. And this lets you see, for example, it's showing here, right here when it called the fraud service, there's a gap of about 20 seconds from about here to here. That should not happen. Like there is no reason for there to be a 20-second pause there. So that tells us that there's a problem, probably in the fraud service. And we could drill down and look at logs and for that specific invocation and, try and figure out what actually was going on. Look at the database to see if, was there a really big query running right then, or did something happen? It lets us sort of do our problem determination and figure out what's happening in the environment. Andy, tell me when, do you want to take over here?
My turn to talk about that.
Okay, go ahead.
So secure secrets management, we're going to talk about a little bit Vault, what it does and why it's there. That's very important. So we deploy probably, it's almost a de facto standard, the HashiCorp Vault into this solution. What you use it for is you can store secrets, and the secrets are encrypted, stored in an object storage bucket, which is a sort of an OCI component there, but you could also choose to store the information in the database if you'd like to. When we deploy, you can say you either want it having a development or a production mode. Development mode and production mode functionality, there's no difference. The only difference is if you reboot or restart your environment, the development mode will not persist the values. The Vault is using object storage. We are using OCI Vault for what we call auto unsealing. And auto unsealing, it means that when you fire up the vault, normally you get 5 keys, and those 5 keys needs to be stored secretly somewhere, and 5 different people and all those kind of things. But to simplify that, we're using a vault to auto unseal the vault, the HashiCorp vault. It's obviously available for all the microservices to store properties in this vault. The Spring Cloud can use Vault or not, or you don't have to use the cloud. The vault itself is very integrated into Spring. And it works the same way as the config server. Basically, you can do injections of username, passwords. Vault has an enormous amount of plugins you could put in, like auto-generate database credentials, key value stores, PKI keys, all these things they can do with that. So it's a very, very powerful product. We deploy the community edition. So if this is going to be a heavily used component, I'd probably recommend to upgrade this into more an enterprise edition with full support from HashiCorp. So another key feature for the microservices backend as a service is scale on demand. So once you deploy your application, you don't have to worry about the right sizing of the application, if you will. You probably have to do an initial sort of thing, say, hey, we need 3 nodes, we need as many CPUs and things, but you start with the smallest size you can, kind of, and then you want to scale that automatically based on what the demand is. I mean, what kind of workload is doing. And you can do this both for the Kubernetes cluster and the autonomous database. And you can also scale within the cluster itself. I mean, you can also do auto scaling there. So when you deploy the Oracle Spring Boot or Oracle backend for Spring Boot, you can opt in or opt out of using it. It's I would say for development environments, probably not so useful, but as soon as you go a little more production, you probably want to do that. It's nothing secret there. And then the developers need developer tools to be able to build applications. So we're going to talk a little bit about the CLI. First of all, we built a Visual Studio Code extension. There's a little O down there on the left-hand side you see there. Basically, you can deploy applications. You can look at all these platform services like the Grafana, the Spring Admin, the API 6 consoles. You can tunnel up to get access to them. The applications running here, we have the account, the credit score. You can see a look at them. You can deploy applications. And in the bottom there, you can manage the config server too, like a create, read, update, delete type of application to make sure that you can store your values so you can inject them into your component. And this is just natively built into the Visual Studio Code extension. We're talking about building an IntelliJ extension too, but it hasn't started yet, but we're talking about it. And then when you create the Spring application, you just use the Spring initializer. You pick the language Java here, and when you do this, you get access to all these Spring Boot starters for Oracle, from Spring, like JPA, the config, the Eureka client, which is if you want to use that. There's a lot of things. We also integrate with the SQL CL, which is the more modern SQL Plus, I would like to say that, and Liquid-based for schema, CI, CD. And you see the videos there, picked a bunch on Spring Boot starters. There are more and more coming there, and it generates this project. And you can see, basically, it's very quick to start. Spring Boot makes it really easy to build an application in Java. Oh, it's building something there. Anyway, we also provide a command line interface called Aura CTL. It's a CLI. So like me, I like command line stuff. So this is the equivalent of the Visual Studio Code extension. In fact, the Visual Studio extension and the CLI uses exactly the same backend to do things, but you can do bind the application to its service, and you can configure, modify the config server. You can deploy an application or service. You can list them. You can look at them. This might be useful too. Let's say you want to automate some testing or scripting for deploying applications. You can use the CLI for that too. And I think it's time for your voice, Mark.
Alrighty. So let me talk a little bit about mobile app dev. We include the option to have a mobile backend as well. So when you install the Oracle backend for Spring Boot, you can tick a box and you will also get a mobile backend based on Parse platform. And we include that because we think that microservices and mobile really belong together. People are all backend applications have a front end, and mobile has become like a really dominant platform, and we think it just makes sense to include them together so they can access the same data and the same authentication and all that kind of stuff. So we base our mobile components on something called Parse. Parse was a company that built this platform originally. They were acquired by Facebook some time ago, I think around 10 years ago, if I remember. And I don't know if you recall, Facebook went through a period where they were offering hosting services that you could write an app and host it on Facebook. So this is the technology that they used for that capability. They did, decide after a couple of years that hosting apps was not really their core business, and they open sourced this. So Parse now is like an open source community that has continued to evolve this platform. So it is written in JavaScript. It runs as a Node.js process or many Node.js processes. It uses a JSON data predominantly. So it lets you basically use the native data types. So if you were writing an Android app in Java, for example, your data would be Java objects, and that's what you would give to the API. If you were writing, a Flutter application, it would be a Dart object, and so on. But in the backend, they all sort of end up as JSON in the database. So it provides a bunches of features like we talked about earlier, the ability to store data and do queries, get the data back, all kinds of query things like filtering and grouping and limiting and all that kind of stuff. It has a live query option so that you can essentially subscribe to the result of a query, and it will push a message out to the device when a new record or document exists that meets the query criteria. It has user authentication, access controls. You can do joins between different JSON documents. It has GraphQL support for large files that you might not want to bundle into your actual application bundle that you distribute onto the mobile device, but you want to serve through a content delivery network on demand because they're too large to send out to all of the devices, for example. And then all of the other stuff that you would expect from mobile, so like location support, so you can do things based on the location of the device. There's on-device storage, so if the device goes offline, like for example, if the person takes a flight and they go into airplane mode, your application can still work and save data locally and then sync back up with the server when they land. Push notifications, microtransactions, all that kind of stuff. And like I said earlier, there's APIs in all these different languages. One thing I will say is it's surprisingly super easy to use. Like when you start developing an app with the Parse API, it is just so it's surprisingly easy. Like, I don't know if when you go and have the experience of learning a new framework and there's all this big learning curve, like this is really very, very simple. So, and very powerful. So it's been really exciting for us. It does have a developer focused dashboard that looks like this. So this is not going to show you things like, compute shapes and subnets and virtual cloud networks and that kind of stuff. This is only going to show you the things that your mobile app developer cares about. So, the collections of data that they created and the data that is stored in those, configuration that they might want to push out to devices, push notifications, and, querying devices based on, for example, the device model or the operating system or the location or the type of user, and sending out a notification. Those kinds of features that a mobile developer cares about, that's what you get in this UI. Obviously, there are those other UIs for those other people who do care about those other things, but Parse itself, the Parse dashboard that you see here, is really focused on just the things that the mobile developer cares about. This is an example of what the Parse SDK looks like. This is React Native code in this example, and basically all you do is include the library, as you see here, require Parse React Native. It actually uses asynchronous storage in React Native, so you also need that. And then you just need 2 bits of information. You need the endpoint for the Parse backend, and you need some kind of key that's used to authenticate to it. So once you've done these 4 lines of code here, you basically have the Parse APIs available anywhere in this application. So here's an example. This is a standard React Native component, and what I'm doing here is creating a new Parse backend object called a bank account, and it's got these fields, and I'm setting some values, and then down here doing a save. So this is what it looks like to create an object and save it to the backend. It's very simple and straightforward, and you notice this is all normal JavaScript code. There's nothing special with the objects. It's just using the native JavaScript objects. If you saw this in another language, it would similarly be using the native objects for that language. So here is another example. This is an example of running a cloud function, which I forgot to mention. So a cloud function basically lets you run code on the server side. So for example, say you wanted to get a whole bunch of data and do some joins and filtering and so on. You don't want to send all of that data across to the mobile device and do that work there. You want to do, all that work on the back end and then just send the result across to the mobile device. So Cloud Functions basically lets you do that. So we would run a bunch of code on the back end. This one here is saying, get an account balance. So you can imagine on the back end that might need to go get all of the transactions and then go through them and add up the numbers or something like that. It's probably not a good example because you probably would have the balance stored somewhere, but just for the sake of argument, imagine that you had to get like hundreds and hundreds of records and add them up to get this result. So that's the kind of thing you might want to do on the server side, and then just send over the one number to the mobile device. Here's another example. This on the right-hand side is our Cloud Bank demo application, which Andy will talk a little bit more about later on. This is written in Flutter, and in this scenario here, it's running on an Android phone or an emulator. So Flutter is interesting because it lets you write applications that will run on any screen from a single code base. So, for example, this Flutter code, when we have this sitting out on GitHub, if you wanted to try it out, you could take this code and run it as an Android application, or as an iOS application, or as a normal web application in a browser, or as a native Windows application, or a GTK application on Unix, and so on, all from the same code base, like literally the same code, which is really, makes it very interesting because, if you look at other alternatives like React and React Native, which are the dominant, cross-platform libraries for building mobile apps today. If you wrote a web app in React and then you wanted to make it also available on mobile devices using React Native, they're very, very similar, but they're not actually the same. Like, you do have to go and change the libraries from React to React Native. Some of the widgets have different names. Some of the widgets are different. The layout is done slightly differently. So it's very similar, but not the same. So, Flutter is interesting because it's literally the exact same code, and it will run on all those different, screens. All right, back to you, Andy.
Sorry. Yeah, so let's talk about a little bit how you can learn more about this. We have a YouTube channel where we publish videos about microservices development. We're introducing the Oracle backends for Spring Boot. Paul, our colleague, talks about long-running actions, how they work. All kinds of videos. So we try to produce them quickly and make them short and neat so they're interesting to watch. We also, on the left-hand side there, if you click on that link or go to that link, you will go to the documentation for the Oracle backend for Spring Boot, and you can learn more about all the components there. There's also a wonderful video of me and Mark, the bobbleheads, introducing the Oracle backend for Spring Boot. So you can enjoy that video and make sure that we get our royalties for that. Also, we have built something what's called a live lab. I don't know if you're aware of that, but Oracle has this wonderful, extremely cool website where you can run live labs, learn about Oracle technologies. And so we have built a live lab around the Oracle backend for Oracle Spring Boot, backend for Spring Boot, where you are going to build on Spring Boot microservice that's called accounts. You're going to deploy a number of microservices. You're going to implement the saga pattern or the long-running actions to manage data consistency across the microservices. You will also extend a mobile application or Flutter application to add what we call like a cloud cache payment feature, so you can allow users to send cash to anyone instantly. There's also components where you're going to learn about operations. How do you see the observability, the workflows? You will also learn how to expose the APIs through the gateway. And finally, what we'll do is we give you the full Cloud Bank application so you can deploy that and play around with the platform. So this is how the Cloud Bank kind of looks like more in a picture. The account service is the one you're going to build from scratch. The platform services, we're using a service registry, the config, vault, and transaction manager for the saga. We provide you with the customer payment and the credit score microservices, all of them running on the PDB, obviously, because that's the way you do it. We have the Flutter mobile application on the left-hand side, where you're going to add a feature to that one and talk through the API gateway to the backend services. So the next slide would that kind of show you a little more how the flow of the application is. So you got the mobile app on the left-hand side talking to the API gateway. The mobile app is using the Parse API, and you go to the applied credit card application there. And the gateway talks to the various backend services which are not exposed to internet. The only way to get to them is through the API gateway. So you're going to do list accounts, get a transaction from the account services, the transfer services send cash, you get a credit score from the credit score application, and so forth. We also would like to offer like a mini workshop if you feel that's something very important. We are very happy to do like a personalized mini workshop. We'll learn about topics like Kubernetes, Oracle Spring Boot, backend for Spring Boot, polyglot development, the converged database, name it, that has something to do with microservices and development. We'll customize an agenda, work with you guys. We can do it on site depending on where you're located. I cover Hawaii and Bali, and Mark does the rest of the world. Or we can do it online over Zoom too, which works very well. There's a sample agenda there. I mean, don't hold us to that agenda, but just if you think it's an agenda, 9 a.m., 4 p.m. with a lunch kind of thing. So going there, but let's open up for questions. If you have, raise your hand or send it over on the QA. And if you move to the next slide, Mark, I think we have a little, while we're talking, please take that survey and let us know if you wanted to get in touch with you, or you just wanted to leave information about what's going on. I haven't seen any questions. Have you, Mark?
Not yet, no. Yeah, so if you'd like to ask a question, I think you have to like do raise hand or something, and we can unmute you, I think.
Oh, hit the QA button on the bottom. I think you got a QA thing there you can ask. Okay.
And if there are, yeah, go ahead. If there aren't any questions, I'll just say thank you very much for coming along. We did record this, and it'll be available to after the session is finished, as is normal.
The next slide, maybe, so you can show us the contact information if they just want to shoot us an email or something.
Okay, yeah, cool. Yeah, you know, if there are other topics that you would be interested in hearing about from Oracle at a future webinar, please do feel free to let us know or get in touch with us. If you have any feedback on what we talked about today, we would love to hear from you as well. That's about it.
Thank you.
Let me stop the recording.